Hi there. So, if you have ever felt overwhelmed by all those Python tools out there, trust me, you're not alone. I started with VS Code and Fast API framework, and I have been dabbling in building APIs and AI/ML. But recently, I've been exploring Google Colab and Jupyter Notebooks, and it has made me realize that beginners need a clear map of the entire Python ecosystem. So in this video, I'll walk you through the most common IDEs, frameworks and libraries that you will encounter when you're working in Python, whether you're building web apps, crunching data or training models. So without further ado, let's break it down. So before diving into the IDEs and different tools and frameworks that we basically use, let's actually check out what is Python. So we can define Python as a high-level interpreter-based programming language, which allows the programmer to do programming in multiple paradigms and is known for its simplicity and readability. It's one of the most popular programming languages currently. But what makes Python so special? Let's look at some of the features and the terms that we used while defining Python. First off, we will check what do you mean by high level. So high level basically means that the language is very much closer to English language. So Python has very much of a readable syntax. It enhances the readability and reduces the learning curves for beginners. And also, if you have done some programming in C, you would have to use calloc, malloc, and realloc functions for memory management. And you have to do that in your code multiple times. Otherwise, you'd be getting undesired outputs or errors. You don't need to worry about memory management or low level operations like that. In Python, the complex stuff is all abstracted away so that you can actually focus on logic building. The next, when we were defining Python, we said that Python is an interpreter based language. So what do you mean by an interpreter, and how is it different than a compiler? So both compiler and interpreter are basically translators for your system, and they translate the code written in a high level language into machine code which your system actually understands. So a compiler basically scans the entire source code and translates it into machine code before the program runs. So in the process, it generates a separate file, often called as the object code or executable, which can be run independently. Then, when we talk about an interpreter, so an interpreter reads and executes the code line by line, translating each statement into machine code on the fly. So, in this process, actually, there is no separate executable created, it runs directly from your source code. So, when we talk about Python, so Python code runs line by line using an interpreter. So, you don't compile it like C++ or Java, which makes debugging and experimenting much easier. So let me demonstrate this with an example here. So I'll be writing a small Python code here. So I'll be taking simple print statement and I'll be printing hello world first. Then I'll be initializing a variable and I will assign a value 10 to it, that I'm going to print this value inside this particular print statement. And after that, I'm going to take in y here, and y I'm going to initialize as a string. So I'm going to type in hello in this string. So, and I'm going to print the y over here. After that, I'm going to print z. Now, as you can see that we have initialized x, we have initialized y. So these are going to print, but we have not really initialized z. So this should give us an error over here. So let us run to see if the program actually runs, executes or not. So I'm going to just, I think I'll have to save it first and then I'll execute it. So I'm going to save it as first.py and it is saved. Now I'm going to run it. We can do it from here, I think. Okay, so as you can see that in the output we have got hello world. That was our print statement. Then there is x is 10, and we printed the value of y as hello. But you are getting the trace back over here. So you're getting an error message that z is not defined or initialized. So if I actually want to run the entire code and there is error at at a particular point, so it actually saves you the embarrassment of having compilation failures, because if we were compiling the program it would not have passed that compilation, and it is actually easier to point to where the exact error is when we are interpreting the code rather than compiling the code. So if I'll actually try and remove this line and paste it somewhere else, so here on, and then I'll also run this program once again. So if I run this program again, I get the hello world correctly. But after this x is initialized and we are trying to print the z over here, and this line actually is going to give us an error. So it is giving us an error. So the program execution breaks where you get an error. The point in code when you get an error, the program execution actually ends, and the remaining lines will not be executed after that. So this actually shows us that Python is basically an interpreter based languages, and the code runs line, the execution runs line by line. Another feature of Python that makes it so popular is dynamically typing. So in Python you don't really need to declare variable types. So Python basically uses type inference, which enables Python to figure out what the type of a particular variable is at the runtime. Moving on, so we also mentioned that Python supports multiple programming paradigms. So let us actually establish what a programming paradigm is. So a programming paradigm is basically a style or methodology of programming. So it defines how you structure your code, how you think about the data and the behavior, and how instructions are executed. It's not about the language itself but how you use it. Python, for example, supports multiple paradigms, which is why it's so versatile. So Python supports procedural, object oriented, and even functional programming styles. So let us explore these multiple programming paradigms that Python support with some examples. First off, we will be starting with procedural style of programming. So functions are also known as procedures because functions are basically a set of instructions that perform some task. So, procedural programming is a style of coding where instructions are executed step by step using functions and control flow to manipulate data. Let us see an example of this. So, I'll create one new file and I will name it as procedure.py, and I'll just create this file real quick. So in this, what I'm going to do is I'm going to create one function and I'm going to call it as greet, and I'm going to pass in a variable called name, and I'm going to return this value. Now what I need to do is I need to call this function once I have declared it. So for example, I'm going to call the variable with the value Alice. So when I am going to execute this, it is going to print hello Alice. You can also add any other functionality that you like. You can add any numbers, or you can perform some specific task. It is basically a set of instructions, so you can give multiple statements in this function declaration, and then you can just call this function from here. What do we actually use procedural style for? So procedural style of programming is best for simple tasks when you are writing small scripts or utilities. And then talking about object oriented programming. So object oriented programming is a method of structuring code around objects that encapsulate data and behavior using concepts like classes, objects, inheritance, and polymorphism. It is best when you are modeling real world entities or behaviors when you're building scalable and maintainable applications. For example, like web apps and modern web services. So let us see this with an example. I'm going to create one file and I'm going to call it as object.py, and I'm going to create this file. Now in this, what we need to do is that we need to create one class. So I'm going to type in class, and I can call it as anything, but let us call it as greet itself. Then inside this call, I'm going to actually start with a constructor. So as you can see, I have initialized a constructor with self, and I'm going to pass a variable called name in it. So yeah, so inside this, I have created another function that is going to actually I'm going to rename this as greet. So this function is going to return the name that I'm passing to it. So since I have created this a class, so I'm need to create an object of the class. So I'm going to write g equal to greet, and I'm going to give my name over here. So this is done, and after I have created an object of the class, I'm going to use this object to call the function inside the class. So this is the code, and I'm going to run this code. So as you can see, the value that I passed in the function in the call is being printed over here. This is the most important programming paradigm that you need to focus on if you are working in web tech, if you are creating web applications and stuff like that. Have the functional style of programming. This is a programming style where you build programs by combining pure functions. So what this means that each function is taking some input and returning some output without changing anything, just like stacking Lego blocks to transform data. So most people actually confuse procedural style of programming with functional style of programming, since a procedure is also called as a function. So actually, functional programming is a bit different than procedural programming. So procedural programming is more like giving step-by-step instructions to the computer, where each step can change the program state or variable as it goes. Whereas functional style of programming is more like using the functions to get the things done. So functional actually focuses on what to do with data. So it is kind of declarative in nature, and procedural focuses on how to do it step by step. So it is imperative in nature. Let us see one of the code examples. So I'm going to create another file in my IDE, and I'm going to call it as functional.py, and I'm going to create this file. And in this file, I'm not going to create any function and not going to create any class. I'm just going to type names is equal to, and I'm going to create one small list. This is the suggested list from the ID, and I'm going to create greetings is equal to map. And when we talk about functional programming, lambdas actually come into play. We are not going to talk about lambdas in this video, since the scope of this video is too limited for that. But I'm going to explain this, however. So I'm going to just do one simple task. That is, I'm going to print in the name of the person taking from there. So when this is done, I'm going to type in print, and I'm going to just call the list of greetings. So I'm basically doing here is that I'm actually using every name from the list, and I'm going to greet him with this function. So let me save it, and let me just call this. So as you can see, you get three messages: hello John, hello Jane, and hello Doe. So let us talk about this code a bit. So starting with lambda. So a lambda is a small anonymous function, meaning it doesn't really have a name, and it is used when you need a quick function for some small task, especially when passing it to a higher order function like map. So filter or even sorted. I am creating first a list of names, a simple array of strings, and I am using lambda as a quick throwaway function to greet each name to a list. So the map function applies it to every item, and the list actually collects all the results. And when you print it, you print the entire list. Then, when talking about the functional programming, so functional programming is best when you are working with data pipelines or transformations, when you need more concise and expressive code for filtering, mapping, and reducing. Python doesn't lock you into one way of thinking. You can write clean procedural scripts, build object oriented programming, all in the same language. That's what makes Python so beginner friendly and powerful. Okay, so let's check out some of the development environments for Python. But before you go ahead and install VS Code or PyCharm, there is a hidden gem already on your system. It's called IDLE. It's Python's own editor built for learning and experimenting. You get an interactive shell, a clean editor, and even a debugger, all without touching the terminal. If you are just starting out, IDLE is the simplest way to write and run Python code. IDLE stands for Integrated Development and Learning Environment. It's the default editor that comes bundled with every standard Python installation. So if you have installed Python from the official website, you already have IDLE on your system. Now you can either use the Python shell interactively. So the Python shell in idle is read eval print loop, meaning it reads your input, evaluates it and prints the result, and then loops back. Or you can actually go ahead and create your Python script in idle. So the steps involved in creating a Python script are: first you need to open idle, and then you need to go to file and click on new file button. Then you write the code in that file and save it with a .py extension. Then you need to run it from the run tab and then click on run module, or alternatively you can actually press F5 as shortcut for running this script that you have written. Then let's also check out some other popular editors. So first is VS Code on this list. So it is an extensible editor ideal for Python. With Microsoft Python extension, you get IntelliSense, linting, debugging, and Jupyter support all in one place. Its marketplace offers plugins for fast API, autocomplete, Docker integration, Git lens for version control insights. So, and live share for the pair programming. So if you are actually looking for complex programs, you can get those extensions and make your life easy. Moving ahead, so any editors from JetBrains is actually a chef's kiss. So PyCharm is no yet exception to that. PyCharm comes in two flavor. The community edition is fully open source and free for any use. Professional edition adds database tools, web frameworks, support, and scientific tools, but it requires a paid license. So this is also a good interactive tool, actually the best if you actually go ahead and read the critics over there. Then there is Jupyter Notebooks. So Jupyter Notebooks lets you write code in cells interleaved with rich text, markdown, equations, and visualization. It's perfect for data exploration, debugging in small increments, and sharing reproducible analysis. You can install it locally via pip or conda, launch a browser-based interface, and leverage extensions like NB extensions for table of contents or coding. So it is perfect for data science stuff, and it is actually a good alternative to Google Colab if you want to write your code locally without Google Colab. So the last one is Google Colab. It is basically a cloud platform. So Colab, basically speaking, is Google's hosted Jupyter environment with free CPU, GPU, and TPU resources. No local setup is required. You just need to sign in to Google Colab with a Google account. It's ideal for machine learning demos or when your laptop cannot handle big matrix multiplications or complex computations. You can mount Google Drive, install custom packages on the fly, and share notebooks with view or edit permissions. So you can actually have a team and you can actually share your code with them and control access to each of them. Right, so this is how Google Colab looks like. If you check out the ribbon, so there are these small menus that will help you get through with it. And then there are these important commands you can use over here. Then you can check actually add one another cell and add text cell. So what these cells basically are small isolated units where you can actually put your code or your comment. So Google's Colab is basically just uh, Jupyter Notebooks hosted on cloud. So you can add your code cells, and you can add the comments or other explanation for the code in the text cell below it. So let's say if we want to create the a small program for finding the factorial of a number. So I'll add a function in here. So I'm just adding a check for invalid number. Then I'm going to put result equal to 1 inside, and then outside this if, I'm going to start with for I in range 1 comma n plus 1 result I actually. And after that I'm going to just return the result. Now I can actually call this function factorial of 5. So you can actually directly run it from this play button or run button that you can see. And the other good thing is that you can connect to any of the runtime that Google is providing for free. Connect to VMs, or if you want GPUs or any other processing units for your code, like if you're making some machine learning or other programs, then you will definitely be needing those. So you can add from here, and you can also actually push this code to your GitHub with save a copy in GitHub. So by default, all the IPNV files, I mean the collab files, are all stored on your Google Drive. You just need to rename them so that you can keep track of what these files really contain. So I'm going to name it as factorial. So you can see it is already saved in my drive, and we can actually run it and check if it is giving us the correct result. So it seems like there was some mistake with the indentations, and I have replaced this print with return statements. So I'll just run it again, and you can see that factorial 5 is calculated to 120, which is correct. So this is how you can actually use Google Colab. All right, so let's talk about environment and package management in Python. So just to be clear, in Python, an environment is a space where your Python code runs along with all the packages and settings that it needs. Every Python project might need different tools or libraries, and an environment helps keeps those tools organized and separate. Now that you know what Python is, let's talk about how to set up your coding environment. So let's first check out what a virtual environment is. So a virtual environment is like a mini version of Python that lives inside your project folder. It keeps your dependencies isolated so that you don't mess up with other projects. You can share your setup with others, and you can avoid version conflicts. Let's understand virtual environment with the help of one small real life example. Imagine that you have brought yourself an old convertible, but it's bad in shape and you intend to restore it, so you have to bring it home. But you are not going to bring it from the front door. Your home will have all the resources that you initially need, like water and electricity and other tools. In your home, you would be having taps for water, but for restoration and cleaning, you would be needing a hose or pressure washing equipments. So you would rather bring it in your garage. In this scenario, your home is the global environment and the garage is the virtual environment. You can always add more tools to either of these or different versions of tool to your virtual environment. If we'll be needing like Django 3.2 for one project and Django 4.1, 4.1 or 4.0 for another project. So if you install them globally, they'll clash and your projects might break. Now, what do you mean by installing both globally? So when you actually install Python from the standard installation, you install it in one directory in your C drive. So that directory is your global installation. So it will actually help you access from any of the location in your system. So if you install one dependency there, it will be automatically available to any of the folders that you open. That is what globally means in this sense. So let's talk about how to set up your coding environment. venv is Python's built-in tool to create isolated environments. It lets you install packages locally for a specific project without affecting your system-wide Python setup. When you install Python, you also get PIP, Python's built-in package manager. With PIP, you can install libraries from Python package index. As your project grows, you will want to keep track of all the packages that you have installed. That's where requirements.txt comes in. So let us actually check all this on the terminal. I'll show you how you can actually create an environment and how you can add dependencies to it with the help of pip. So let's say that I want to create an environment over here, and I'll do it with the help of the following command: python -mvenv. This means that I want to create a virtual environment, and I can name this virtual environment as anything, but I'm going to keep it as env. And herein I will actually create a folder. As you can see in the left side here, that a folder is created, and it will take some time to actually initialize. Once it is done, all you need to do is activate this environment. So for that, you need to first move into this particular environment. So I'm going to type in cd in env, and I'm going to then add a backslash over here. Then click on S, and I'll click on tab. And when you click on tab, you see that this has changed to scripts folder, and you can actually manually check there is a scripts folder inside it. And once it has come to this, you can just press enter, and you will be inside this scripts folder. Then all you need to do is add a and then tab, and this will actually add this activate command, and you can press on enter. And as you will be seeing that your environment is now activated, and you will be getting this here. Now you can create an requirements.txt file here. So first I'll be actually getting back to the project folder, and inside here I'll be adding requirement.txt file. Right now this will be empty. I'll be just closing it, and now I'll be adding one or more dependencies with the help of pip. So I'm going to type in pip install matplotlib. Let's actually take matplotlib for now, and I will. And as you can see that it has started downloading the particular packages and library that it needs. So it's installing all the collected packages from over here. Okay, so now it has done installation. So I'll just create one file from here, and I'm going to call it as bargraph.py. And inside this, I'll actually create one small code to show you how to use matplotlib. So I'm going to import it as I have already installed it. And then I'm going to add some sample data here. So for sample data, I'm going to actually add some languages over here. And also I'm going to add the popularity of the said languages. And I'm going to create the bar graph over here. So I'll just be using this plot.bar, and I'm going to add the languages on the x-axis, then popularity on the y-axis, and I'm going to use color as sky blue. After that, I'm going to add the title to this uh, bar graph as programming language popularity. And on the X label, I'm going, as I have added, just a second. Okay, on the X level, as I've added languages, so I'm going to put the label as language and the y label as popularity with percentage. And actually, instead of percentage, you can also add scores, but let's go with percentage. And the last command will be to plot dot show. This will actually display us the result. Now I need to actually save this dependency of matplotlib in one of the files so that I can actually use it over and over again. If you push your code to GitHub for sharing with your team or with your friends, if you are working on some projects, so this is super helpful. Or if you are deploying to a server, it ensures that everyone's working in the same dependencies. So to actually uh, freeze the dependencies, you will use this command. So yeah, as you can see that this command executed successfully, and let us check if our dependencies got frozen in requirement.txt. So as you can see that matplotlib got stored here with the particular version that it is using along with numpy. So this is done. Now let us just clear the terminal and run this code that we have written. So I'm going to, and as you can see that you have getting this one pop-up here, and you can also save this figure if you want. So this is how you can actually manage your dependencies and manage your environments in Python. So moving on, there is another tool for Python. So conda is a powerful environment and package manager, especially popular in the data science and machine learning workflows. Unlike venv, conda can manage non-Python dependencies like CUDA, MKL, or system-level libraries. It works with both Python and R and is great for reproducibility across platforms. And we have already checked out how pip is working, and these are the steps, simple steps for actually freezing the dependencies and recreating those dependencies. There are two more package managers, or let's say servers for your Python app. Those are Uvicorn and Gunicorn. So once your app is ready to go live, you need a production grade server. So your Uvicorn is an ASGI server used with fast API. It's fast and async ready and perfect for development and lightweight deployment. And Junicorn is a WSGI server often used with Flask or Django. It can also manage Uvicorn workers for scalable ASGI apps. These tools help you move from local development to real world deployment. So let's talk about all the web development frameworks that you will come across when you're working on Python. So the first one in this list is Django. So Django is a pretty mature and batteries included framework with an ORM, admin panel, templating engine, and built-in security features. It enforces an MTV pattern, making it ideal for larger projects that need user authentication, reusable apps, and a ready-made CMS out of the box. In case you have worked with MVC pattern, so the view component in both MTV and MVC are not exactly the same. So do not get confused with that. And MTV actually stands for model template and view architecture, whereas MVC stands for model view and controller architecture pattern. Moving on, let's talk about Flask. So Flask is a minimal WSI SGI framework that gives you full control over every component. It's unopinionated. You choose your database, form library, and authentication. It is great for small to medium apps. It is good for rapid prototyping and that sort of thing, and also learning the fundamentals of request routing and middleware. The next is Fast API. This is currently a very popular web framework on the internet. It is a modern high performance web framework built on ASGI. Fast API uses Python type heads to auto generate interactive Open API docs, validate request bodies, and spin up an async server with Uvicorn. Its speed rivals Node.js, making it perfect for building scalable APIs and microservices. All right, so let's now talk about the specialized libraries or specific libraries for the Python ecosystem with for a particular use case or operation. So first off, we will be talking about the data manipulation. So we have two core libraries over here. First is NumPy, and then there is Pandas. So NumPy provides fast, memory-efficient arrays and vector operations, and where Pandas is actually built upon the NumPy framework to offer data frame and series objects, which is perfect for cleaning and transforming tabular data. Another popular operation is data visualization. In simple terms, making most of the data with the help of visuals. So matplotlib is the foundational plotting library for static charts. Seaborn sits atop matplotlib to simplify statistical graphs, and Plotly lets you build interactive browser-based dashboards. Moving on to machine learning. So scikit-learn offers classic algorithms like regression, clustering trees with a clean API, and then XGBoost specializes in gradient boosting for high performance tabular models. For deep learning frameworks, you can use TensorFlow and PyTorch because these are the two dominant frameworks. TensorFlow excels in production deployment. PyTorch is beloved for research and dynamic graphs. Another very common operation, or let's say work that we do with Python, is web scraping. So first off, requests handle HTTP calls with ease. Beautiful Soup parses HTML or XML into a searchable formats. Scrapy, which provides a full scraping framework with pipelines and crawling rules, is also a good and modern application or framework that you can choose. Where if you use Scrapy along with Selenium and Spider modules, you will create a really great scraping project. Moving on to image processing. So there are a few libraries or frameworks that actually help here. First is OpenCV. This gives your computer vision tools, filters, objects detection. Then there is Pillow, short for PIL, handles basic image transformation such as resize, crop, format conversions. When we talk about NLP and LLMs, Hugging Face transformers for state of the art language models. And there is also LangChain to actually help you orchestrate the prompts, the chains, and agents for complex LLM workflows. So that was your Python starter kit. Now, whether you are building apps, you're building websites, or scraping from websites, or even training models, if you have found this helpful, drop a comment below, mention your favorite Python tool, and don't forget to subscribe for more dev content, tutorials, and vibe coded chaos. See you in the next one.